All right, this is the lesson for translating and solving inequalities. We have solved one step, we have solved two step, and now we need to interpret a statement to create the inequality for that. So you're looking at some statements in front of you. You should be opened up to it right now. The one thing I'll remind you is that since you can see some statements in front of you, you need to pay attention to some key words. This is not in your packet, but there are some key words that basically help us know which inequality symbol we should be using. All right, when we hear maximum, at most, no more than, we're using the less than or equal to symbol. When we hear smaller than, less than, below, fewer than, we're using this one. So I've given you a sheet that you can refer to, but these help us know which symbols to use because that's a tough thing to always remember. Okay, so refer to your sheet when needed, but keep it by your side as we're going through this because these come up frequently and we want to know which symbol we're talking about mathematically. That being said, let's go to some of these examples. I'm going to do some, and then I'm going to have you pause and do some on your own. Let's start with number 1. 9 less than 9 times a number is at least 36. Now you can already see some of my highlights that kind of pull out some keywords. One thing I will point you to, though, is you keep seeing this phrase, a number, and they don't tell us what number, okay? So again, think mathematically here. When they don't tell us what number to use, how do we represent a number? And it tells you down here, remember, a number means it can be any number. So we represent that with a variable, all right? We're gonna use X over and over again, or whatever variable you choose to use, but we're gonna use a variable when we see that. So 9 less than 9 times a variable is at least 36. All right, so the first thing we've got to do is we've got to think, what does this mean? Well, 9 less than 9 times a number, that's going to look like this. 9 less than 9 times a variable. All right, so 9x minus 9. And that is at least 36. So that means it's equal to 36 or more. So we're going to be using the greater than or equal to symbol for this one. And once we've written our inequality, now we want to solve it. Okay, we want to copy that down. 9x minus 9 is greater than or equal to 36. And now we go through our steps of solving inequalities. Okay, we undo that subtraction first. So we add 9 to both sides. And that gives us a new inequality, which is 9x is greater than or equal to 45. And now we want to get rid of the multiplying by 9. And so we divide both sides by 9. And we end up with x being greater than or equal to 5. Okay, for this to be true, our value of the variable needs to be 5 or more. Okay, that's what we're solving. Now, we're not graphing this one in this lesson. Okay, we could graph it, but we're not graphing these. We're just writing them and then solving them. So really, we're translating to get to here, and then we're solving. Number 2, the sum of 4 and a number divided by 2 is less than -6. Well, this is going to be simple because that's just our less than symbol. All right, we're going to use the less than symbol. But look at the other part. The sum of 4 and a number divided by 2. So we have to do some adding of 4 and our variable, and then we want to divide by 2. So I wrote it like this. The sum of 4 and a number divided by 2 is less than -6. Now, you might not have written it like that. Sometimes people do it like this. The sum of 4 and a number divided by 2. This is the same as this, essentially. These are equivalent. So if you wrote it this way, that's fine. If you wrote it this way, that's fine too. But however you wrote it, now we want to solve it. Okay, we want to come over here and we want to, first of all, get rid of dividing by 2. Okay, we want to get rid of that first because this is actually needing to be performed. And so we want to get rid of the dividing by 2 first, and then we can get rid of that adding later. So if we get rid of the dividing by 2, we multiply both sides by 2. You can see up here, the left side times 2 and the right side times 2. And then we end up with 4 plus x is less than -12. Now we can get rid of the adding of 4. Okay, So to use the opposite of that, we would subtract 4. And that leaves us with x is greater than negative 16. Okay, negative 12 minus 4 results in negative 16. So that's our solution. For this to be true, we can only plug in values where x is less than negative 16. That's what we're doing here. All right, I'm going to do a couple more with you and then have you try some. Negative 5 plus triple a number just means 3 times a number, is no more than 16. Negative 5 plus triple a number. Okay, so negative 5 plus 3 times a variable will be no more than 16. Okay, so that means we want to use the less than or equal to sign. You can refer to your sheet if needed, but negative 5 plus 3 times a number is going to be no more than 16. Okay, it's going to be less than it or equal to it, but it will not be more than that. So once we've established our inequality, now we come over here and we solve it. We rewrite it first, and then we want to start working our way through here. Well, we want to get rid of the negative 5, so we add 5 to both sides. These will cancel out. These will result in 21. So we really have that. 3x is less than or equal to 21. And now we want to get rid of multiplying by 3, so we divide both sides by 3. And over here we will have x, and over here we will have 7. We did not need to change our symbol at all because we didn't multiply or divide by a negative number. So that's our solution. X needs to be less than or equal to 7 to make this true. If it's not, then this won't be true. So there's a whole bunch of values that will work, but they all need to be less than or equal to 7 for this to be true. And number 4, the difference of 8 and 6 times a number is a minimum of 68. So let's look for some keywords here. The difference means we'll be subtracting 8 and something else. Well, that something else is 6 times a number, so 6 times a variable. So if I look at what that looks like, the difference of 8 and 6 times a number, that's where this came from, 8 minus 6x. And that will be a minimum of 68. That means it will be at least 68. It could be equal to it, but could also be more than that. So we want the greater than or equal to sign. And there's your 68. So this value over here will be at least 68. So if we solve this, we rewrite it first, and then we want to start getting the variable by itself. So let's get rid of that 8. Okay, it's all by itself, so let's subtract 8 from both sides. That leaves us with negative 6x. This should be a negative 6x here. I'm seeing a mistake. Negative 6x is greater than or equal to 60. And let's see if that mistake kept going. Well, here's what we should be doing, and hopefully you're catching the mistake here. This should be negative 6x from above. We should bring down that minus sign. So to get rid of that minus 6x, that's really a negative 6x. We want to divide by negative 6 on both sides. So this is one where we should flip our symbol, and the work here does not show that, all right? Actually, now it does, but over here it did not show a negative sign. So this solution right here is okay. X needs to be less than or equal to 10. Again, just to point out that there should be a negative 6 right here when we're dividing. But this is the good solution. That one was right. They just left off a negative sign and showing their work. All right. All right. So remember, sometimes you flip your symbol when you are multiplying or dividing by a negative number. And in this one, we did that, which is why we flipped our symbol. All right. That being said, let's look at some that I want you to try on your own. Try 5 and 6 and 7 now. All right. Go ahead and check your work. And you probably should pause the screen just to go through 5 and 6 and 7 and see how you did. So pause it and check your work, and then come back when you're ready to move on. Okay, now we also have word problems that sometimes we got to handle. Sometimes we're dealing with a situation in context, so let's talk about these. They want us to define a variable, set up an inequality, and then solve it. So we're doing what we were just doing. We're just going to throw in one step at the beginning about, let's define our variable first, okay? Number 8, Peter spent half the money on his gift card on coffee. He loaded another $10 onto the gift card. How much was on the gift card to begin with if he now has at least 40 bucks on the card? So apparently he loves coffee, but the unknown here, think about what we don't know. We don't know how much was on the card. Okay, that's the whole point here. We're trying to figure out how much was on the card. Let's let that be our variable. Let X equal money on the card. Now, if we were to write this one out, he spent half of it on coffee. Okay, so 1/2 times what was on the gift card. If there was 100 bucks, well, he only spent 50 on that. If there was 20 bucks, he spent 10 on coffee. So this can be any amount, but half of what was on the gift card is how we show it, 1/2 X. Now he loaded another 10 bucks onto it, so we're going to add 10. But how much was on it if he now has at least 40 bucks? We want this to be at least 40. So we're looking at that inequality right there. Okay, 1/2 X plus 10 is greater than or equal to 40. Now, if we want to solve this one, let's get rid of that plus 10 first. So subtract 10 from both sides, and we end up with 1/2 X is greater than or equal to 40. I'm sorry, 30. 30 right there. But now we want to get rid of this 1/2 X. So we could divide both sides by 1/2, which is essentially the same as multiplying by 2, which is why you see what we did there. We're going to multiply this by 2 because that'll be 1x. We're going to multiply that by 2. And that tells us that the amount of money needed to be at least 60 bucks. Okay, that's how much he had on it at the start. So that's our solution. Now, just to bring this back to summary, our inequality we came up with first, 1/2 X plus 10 is greater than or equal to 40, and we solved it. We came up with a value that needs to be at least $60. So that's this first one. It's a little trickier when you have something in context. You've got to work with an inequality now. Number 9, Megan wants to spend no more than 300 bucks planning a party. She spent $75 on food and wants to buy decorations, $10 each. How many decorations can she buy? Well, that's your variable. Let X equal the number of decorations that she's wanting to buy. Okay, that's what we don't know, so we're trying to figure it out. So we also know that she wants to spend no more than 300 bucks. Okay, so let's talk about that. No more than will be the less than or equal to symbol. Okay, so she's already spent 75 bucks. She's going to spend some money on decorations that each cost $10. So that's what the 10x is. 10x plus 75 is less than or equal to 300. That's her maximum amount that she's going to spend. She can't spend any more than that. So that's your inequality. Okay, we should put that down there at some point. Now we want to work our steps through here. Let's get rid of the plus 75. And that changes our inequality a little bit. 10x is less than or equal to 225. Now let's get rid of the timesing by 10. So divide both sides by 10, and you end up with a value for the variable that needs to be less than or equal to 22.5. So that's our solution. She can buy at most or no more than 22 decorations. Okay. All right, I'll do one more with you, and then I'll have you try some on your own. Number 10, a moving truck can carry no more than 1,480 pounds of cargo. Brian's already loaded some on it, 640 pounds already. He's loading boxes that weigh 70 pounds. So this is something to pay attention to, 70 pounds each, all right? How many boxes can he put onto the truck? Well, if that's our variable, how many boxes he can load, let's let X equal the boxes. And from there, we know that the weight needs to be no more than 1480, all right? So that tells us that our symbol will be the less than or equal to, because the weight can't exceed that amount. He's already got this much on there, so that'll kind of be standing alone. But he's also trying to load boxes on there that each weigh 70 pounds. That's quite a bit of weight. Hopefully he's not working by himself. Maybe he's really strong though, who knows? So this is our inequality though, 640, what's already on there, plus the rest of the boxes he's trying to load need to not exceed 1,480 pounds. So we're starting with that inequality. All right, if you're not sure, just pause it and make sense of the numbers in front of you. But the next step would be to subtract 640 from both sides. Let's get rid of this because we want to get the variable by itself. If we do that, we end up with 70x is less than or equal to 840. Now we want to divide by 70, and we end up with 12. We end up with x being less than or equal to 12. So essentially, he can load up to 12 more boxes on the truck. That's the plan. All right, I want you to try the last 3 on your own and come back when you are done. All right, here's number 11's answer. Go ahead and check that you've established a variable. Check your inequality. Check your symbol. And then see how your solution compares to this one. This is one where we're probably going to round up because we got a decimal answer. That's why we said 127 right there. If you need to study it some more, pause the screen, please, because I'm going to go on to the next slide. All right, in number 12, you should have established a variable of the number of games. You should check your inequality right here, and you should check your work. This is one where we were dividing by a negative, so you should have flipped your symbol down there to establish that they can buy up to 8 games. And number 13, again, let's establish a variable, let x equal the number of miles she can go. And this is the cost per mile, so that times the number of miles plus what they've already charged her, $235, needs to be less than or equal to 15. She's only got 15 bucks. She can't spend more than that because she's really in a bind. If we solve that, we basically find out she can go up to 23 miles, okay? Again, if you need to pause these and study the work a little bit, see how it compares with yours, please do so, because that brings this particular lesson to a close. So you need to make sure that you understand it. If you have questions at this point, you should make sure that we get those asked, okay? Find me, find a partner, find somebody who can help you, but we should make sure we understand those things if they were kind of giving you some trouble, all right? All right, the end.